Welcome once again. Today I'm going to be demonstrating another method of using the XPO co-op piloting system for FPV applications. But before I go on much further, I want to highlight the various systems that we have seen in all of our previous movies. We have seen an FM Airtronics being demonstrated with XPO, a 2.4 GHz Airtronics, FM JR transmitter and receiver, JR 10X upgraded to 2.4 GHz module, also a 12X 2.4 GHz JR. We've also seen a Spectrum 7 channel. We've seen a PCM 8U Futaba transmitter. We've also seen a 9-cap Futaba transmitter upgraded with the fast system. Tonight we're going to be seeing the 9-cap. However, this time it is upgraded with the high-tech, let me see here if I can, with the high-tech 2.4 GHz transmitter system module. And I'm using here two Optima 2.4 GHz receivers. Both of these receivers accommodate up to 9 channels, which goes very well with our 9-channel cap Futaba transmitter. Both of these receivers are bound to this transmitter, and right now I can demonstrate aileron, elevator, throttle, rudder. 6 and 7 for the master receiver are my pan and tilt apparatus right here, tilt and then pan. So this would be the setup for the master pilot who wants to take off by looking at the aircraft and wants to have all 4 basic channels on the gimbals here. Okay, elevator, aileron, throttle, and rudder. However, once this pilot wishes to fly via FPV, by just toggling channel 5, he will pass control of the aircraft from the master receiver to the secondary receiver. The secondary receiver is wired up a little bit differently, where I actually reassign the channels. So I have on the left hand, instead of rudder and throttle, I have pan and tilt on the left hand, and then I've put the throttle back here, and then I've put the rudder over here. Right now I'm using the panning on this gimbal right here, or should I say on this knob right here. I don't use this same knob for the rudder, just because I don't want to have trim issues when I pass the control to this other receiver. I'll explain that a little bit more as we go along. Let's give control over to the secondary receiver. Right here is the switch for channel 5. I'm using the channel 5 on the master receiver to toggle on the XPO and give control of all the servos here to the secondary receiver. These 2 servos here are just installed in the box, but they're actually not connected. I've pulled the connectors out of these 2 servos and instead have the servos of the pan and tilt running into the XPO. So here we go. I just gave control over to the secondary receiver. The wiring of the secondary receiver is actually a bit different. So on the right hand here, I have aileron and elevator. However, the left hand does not have throttle and rudder. The left hand instead has pan and tilt. Okay. The throttle has now been reassigned to the dial back here, the index finger dial, and the rudder has been reassigned to this dial right here. So what channels am I using on the secondary receiver? I'm using channels 1 and 2 for aileron and elevator. I'm using channels 3 and 4. However, channels 3 and 4 are being ported to these servos, not these 2. I'm using channel 6 for this throttle right here, which happens to be set to the index finger. And I'm using channel 8 for the rudder, which is the middle knob So I do not recycle the rudder channel. On this receiver, I have the rudder set on channel 8, while on that receiver I have the rudder set on channel 3. The primary receiver has just a straightforward traditional connection. Channels 1 through 4 are the basic 4 channels. Channel 5 goes to the box to turn on the XPO and give control to the other pilot. And then channels 6 and 7 are being used for the pan and tilt. Of course, this receiver here also has channels 8 and 9, which are not being used at all. I am, however, using channel 8 on the other receiver. An issue can arise with the toggling between the primary and secondary receivers. Just like flying a regular buddy box cable, one must be very careful with the throttle settings. In this case, I have the secondary receiver set to high throttle, and then I observed that this gimbal being lowered all the way down would represent very low throttle setting for the master receiver. Okay, so here we're flying the master receiver. We observe that the throttle channel here is being controlled by the traditional throttle. But when I give control to the FPV mode, the throttle is going to immediately go to full throttle. So you must be very careful not to pass control between these two modes and experience a sudden deceleration or acceleration of the aircraft. As far as the rudder is concerned, the trimming of the rudder is what needs to be kept in mind. When you're flying the regular piloting mode, the trimming of the rudder is done right here, right? So when I give control over to the secondary receiver, I'm using the rudder channel for the panning of the camera. So this camera right here will have the same trim setting as your original rudder on your aircraft. But since I'm using channel 8 now to accommodate for rudder, that happens to be right here. So once you pass control over to the secondary receiver in the FPV mode, you must trim out your rudder on this dial. And otherwise, while flying the FPV mode, you can just leave this dial set to whatever trim conditions makes the aircraft fly, and then not touch that again. What is important to note about this setup is that we're using just one transmitter and generating two modes, where the primary pilot is flying regular control settings, and then the secondary receiver here, which would be the FPV mode, rearranges the channels so we have pan and tilt over here, and then we've rearranged the rudder to here and throttle to there. Something else I have done with this setup is create channel mixing for aileron and rudder and elevator and throttle.